Hello, my name is Matthew Brown and I'm a graduate student at Simon Fraser University. And one of my passions is crystallography and the tools we use to do crystallography. I love the fact that there's such a large crystallographic ecosystem and so many of the components of that can be swapped in and out based on user preference. So, for example, I refine my structures in SC-XRD. I like these small, unobtrusive Q peaks. I like how they're color-coded. I like that I have the res file right here, because unlike OLEX2 claims, there are advantages to writing it yourself, and I get annoyed when OLEX2 overwrites parts of my file occasionally. But I just very quickly solved this CIF based on a crystal I ran accidentally, and you can see I've got a bunch of A-level alerts, crystal description is missing, device type is missing, lots of stuff here is missing. And I would have to, the normal way my group does it is we then go into the CIF file with a text editor, often NCIFers, sometimes Notepad++, and we enter all this in by hand. We go into the various text files that come with out of the Brooker software and we solve the crystal. However, there is another way. While I don't like refining data in it unless I'm doing something special, for example, certain types of disorder are much easier to solve in OLEX2. I do find it very good for its report feature, which you can see here. Now make sure you set, before you use the report feature, set refinement program to shell XL or it will create problems. So let's open up the report thing. The first thing we get is this interface, which has gone through. You have to put all the relevant files. So your P4P, your PCF, your absorbance file, and your least squares file, and I usually just grab anything with a unique extension and put it all in my solving folder. It goes through all of those and finds all the conflicts. So for example, down here, I did not in fact use none as my absorbance correction. I used multiscan. Most of them are rounding errors. Those are pretty easy. I just go with whichever one has more digits. I did not do question mark. I did that number. It's even got this very nice description of the absorbance correction that I used. Brooker Apex 2 CCD. And these two numbers are the same, but they're conflicting with this question mark. And there we go. All those numbers, as well as a whole bunch of other ones, are now automatically in our CIF file. But let's go through. So collection. You need to put your author names and whatnot on the CIF file. So there. I'm the one who submitted it. And I'm the one who operated the instrument. I submitted it, the crystal, I don't know what it counts as submitted way, but I collected it on Sunday and it was completed Monday. Now those are completely optional OLEX2 only extensions, but they don't take long, so I put them in. Crystal, what color was it? Well, it was colorless. It was a plate. There we are, plate. I don't have handy what size it was. That's in Apex 3, but you can put in your preparization details. So slow evaporation from this was MECN, I believe. Yeah, I didn't write it in the file name. Well, let's just say slow evaporation from whatever. For me, that would actually probably be more your reaction. For me, my reaction and my crystallization are the same thing. So you could put mitogen or something like a dual thickness mitogen. I will put in, I've got it written down in a file that I just copy and paste in the exact type of mitogens we use. Crystal image, this is more for the actual report I'll show you in a second than the CIF file. Diffraction. Oh, look. So one thing you can do is actually write out for your instrument. So I've got two things like, what's your detector area resolution? What type of detector do you have? what type of measurement device is it. All this stuff, you write it out once, and then I've got one written for copper and one for molybdenum. You just select which one is relevant, in this case molybdenum. Boom, all that stuff is automatically in there. What diffraction temperature? That's probably a bit more realistic. And what was your cell measurement temperature? It automatically grabs those of your files. You can put in any special details here. I've used those a few times. For example, okay, here, if it used SAT-ABS, this works perfectly. If you use TwinABS, you have to fill it in manually. Though it used to work with TwinABS, it stopped at some point, and you just have to do it the old-fashioned way then. It's still, I mean, usually you use SAT-ABS. Publication, contact author. So let's add some authors. So let's say I'm the lead author on this publication, and then my boss is the primary author. So I now say contact author is him. That will now add to this CIF file. Now most people, when they do a merged CIF, will put a one combined author entry at the top, and then each crystal structure won't have an author entry. But there's no reason you can't have individual author entries for each CIF file. So for example, on my first paper, I did the work on almost every crystal structure completely by myself, except for one of the early ones a more experienced crystallographer helped me with. So he was a co-author on the paper, and of course he was listed as a co-author in the CIF file, but it actually specifically said in the CIF file which structure he worked on, because why not? I'll show you a nice little trick in a second involving this. So we've now got our authors there. You can put in request a journal. I like, where is it? Let's say Dalton. I've submitted Dalton before. I don't know what that actually does. I don't use it. But citations, it in this case has not been very helpful. It's just added its own citation. But maybe if I hit refine, and here, oh, it's now figured out that we're refining using ShellX. In fact, it's figured out we're using ShellXL. So if I go back to report, if I make report, in fact, solution package, I solved using ShellXT. If you're using the Brooker specific version, which I don't recommend because ShellXT was updated recently, you can put in XT there. If you're using OLEX solve, Superflip, SIR97, it's all there. And then what use? So if I were using there, if I actually was doing it the old-fashioned way, you could pick Patterson. So there, and now it's added. If you look down here, it's now added the solution citation as well as the refinement citation. Now, what this won't do out of the box is stuff like, I also used ShellXLE, so I have to cite that. Maybe you used Platon for AddSim or Squeeze. Maybe you used Rotax or CellNow. Apex 3 you should cite, and so on and so on and so on. It can't do that. There is a plugin if you want to add it. Extension modules. There you can put in Report Plus. I have found it is still buggy the last time I used it. I wouldn't recommend it quite yet, but it looks really nice when they stop a couple of the issues. So I was using an academic license, which you have to renew every so often, and it just would not let me renew, and it wouldn't let me uninstall it. So I had to actually reinstall OLEX2. But when it's done, it'll be very nice. But there are ways of adding to these. I will link to a video by the OLEX2 people showing you how to do that. And it's still easier if you put those citations in a file. You then just merge the file in, and it's done. So it is still a little bit easier than opening a text editor. References, yeah, you put that in at the end. What paper you're doing if you want. Source files. So you want to go here and check that it's used the right ones. Because, for example, if you just do this in the main Brooker directory, thing it'll be easier, and you've solved your crystal more than once, maybe one time you did it with twinning, one time without, it can grab the wrong one. Or, for example, P4P, it will often grab spacestat.p4p, not your final P4P file. So make sure you come and check these. But then, make sure this option here is set to ignore CIF, because there's a difference between how SHLX and CheckCIF do HKL inclusion and how OLEX2 and the official recommendations are. You want to be CheckCIF compatible, so you then press merge CIF. It will pop your CIF file up. Oh look, it's got my name, my academic affiliation, because I put that in once, and now it knows to add that. It's got my boss's email, it's got those citations, and all those numbers we added are just automatically in here. So now I can even send CheckCIF. Boom. This will take a moment. And now we have a CheckCIF here. There we are. So you can see, alright, so I didn't put in the crystal dimension. There's some problem with the crystal. So those are two problems with the crystal. These are all crystal dimensions. And then there's some problems with the crystal. It's not too bad. Let's look at the oh no, that's the report. So, compared to what? Now, let's re-refine this with SHLX. So let's overwrite those ones. And, oh, here again is the SHLX entries. And we've got a whole bunch more stuff we have to do compared to OLEX2. It's all done. And you saw that was pretty fast. So that's what I like to use OLEX2 for. And they're actively improving it, so I expect that this will actually get better. I'd really like it if it automatically could tell if numbers were different by a rounding error, as that would save a ton of collective 1-2 second clicks over time. But as you can see, it's quite nice, and I will link to their video which shows you how to expand on this, so that you don't have to manually edit the CIF file as much. You can make up files which you then will set a meta CIF file, and it'll just automatically merge in. It's very nice, and I'll link that video by the OLEX2 team. Thank you for listening. I hope this helps, and I hope it wasn't too meandering. I'm just getting started in writing these tutorials, and as you can probably tell, I'm not using a script. So thank you very much.